All right, both problems 4 and 5 involve taking survey data from pie charts and sort of interpreting them into contingency tables and Venn diagrams. So half the battle here is just being able to take the data out of the pie charts. So the pie charts give us percentages, and we are told, if we take a look at our data here, that there were 38 total responses. And then we're given sort of percentage breakdowns within that. So that's why, like on our contingency table, we see a 38 down here at the bottom. Now, when I'm going through and doing this, the first thing I'm going to go through is figure out these totals, and then I can sort of backfill the rest of my chart. And so to do that, let's start with age. So the under 20, I might as well use blue since it's blue in the table, is that 68.4%. So if you want to do percents of a number, there are sort of two ways to approach it. So one way is to turn this into a fraction. So a percent's going to be something like 68.4 out of 100. It's out of 100. So we want that percent of the total, and the total is 38. And so I would put this expression into my calculator, and when I do, I'd get a decimal. And I don't want a decimal. I can't have a fraction of a person. So I round my decimals, and you might be going, well, do I round up? Do I round down? That's really up to you in the end. Because of this sort of total of 38 here, it should work out in the end that you get 38. In this case, I think you round up to 26, if I remember correctly. And so that's one way to approach my percentages. So another strategy so let's try the 20 to 24, we have 18.4, is to turn that 18.4% into a decimal. So 18.4%, so decimals would be like dividing by 100, and so what happens is that decimal place ends up moving twice. So I would have the decimal form would be 0.184, and then still of the 38. So it's the percent of the total. And in this case, then we'd end up with 7. Still not to our total of 38, so we need to keep going. The next one through, we have 10.5. So 0.105 of 38. And that came out to about 4. And now is where obviously there's no percent with the last one, but I can sort of total here. 4 plus 7 is 11, plus 26 gets me to 37, which means in that last one, I would have at least one person. And I could have just totaled that row and gotten there, but just to sort of double check. I like to double check throughout my table that everything's sort of matching up and working out perfectly. Okay, we want to do the same thing with the number of credit hours. Now I'm going to start with the easy one. 50% is more than 12. 50% of 38 would just be half of 38, which is 19. So I'm going to just put a 19 there. All right, then I can sort of move over, and let's do the yellow one next. So yellow is 9 to 12 credits, and we have 21.1, so 0.211 of 38. And that would come out to about 8 people. And then, moving right along, 5 credits is 0.184 of 38. And that one came out to 7 people. And so again, I can sort of total and figure out my missing value here would end up being 4. 11 plus 8 is 19, 19 plus 19 is 38. And now I can sort of backfill my columns in. So I sort of, I filled in all my totals, and I can sort of, each column and each row needs to total the numbers they show. So here I have 0 plus 2 plus something plus 0 equals 4, so this value must be 2. Same idea here, 5 plus something plus 1 needs to equal 7. Well, it already equals 7, so that must be 0. And then I don't have enough to fill in this row yet, but why don't I start looking across? So I have 2 plus 1 plus something plus 1 equals 4. It already totals 4, so that must be 0. Okay, 0 plus 1 plus something equals 8. That must be 7. So you see how I'm sort of backfilling stuff as I go? 2 plus 0 plus 1 plus something equals 7. So I have 3, so this would need to be 4 for me to get to 7. 4 plus 1 is 5. I end up at 19, so 19 minus 5 is 14 in that upper corner. And, you can do a quick check across and, the columns that everything sort of matches up and works well, and so forth. Okay, now we're going to take our table and we're going to answer some questions with it. So, what percentage of students are 25 years old or over 25 years old and taking less than 8 credits? So we're looking for the overlap here. So percentage of students that are over 25 and taking less than 8 credits. So we're going to sort of, less than 8 credit line, and I would be like, on this side, and then over 25. So I'm sort of blocking it off. So it'd be all the students in this group right here. And so that would be 2 plus 1 plus 1, which is 4 students. And it's 4 students out of our 38. And then we would times that by 100 to turn it into a percent, which would be 4 over 38. And I didn't put that in my calculator in advance, so I now need to do that. 38, which would be about 10.5%. All right, so that was sort of how I reasoned my way to that one. Now let's do the next one. And I like to sort of erase my work in the table so that I can sort of see what I'm doing. All right, how many people take between 5 to 8 credit hours or between 25 and 29 years old? So I actually like a highlighter for this one. So 5 to 8 credit hours would be everything in this column. Okay? And then or between 25 and 29 years old would be everything in this row. Notice there's overlap, but we want to make sure we don't count that overlap. So when we go through, I just sort of add what I see. So in the 5 to 8, I have 5 plus 1 plus 1. So that's the 5 to 8 credits plus 2 plus 1. Notice I didn't add that overlap again. I just didn't count it. I'm just sort of counting each number highlighted once. So 1, 2, 3, 5, 10. So we have 10 students. The other option, another way to sort of approach these OR problems would be to sort of take the row totals, 7 plus 4, but then you want to subtract out the overlap because you counted that one twice, and you would also get 10. It's just another way to approach those OR questions. All right. So let's erase our highlight because we got one more problem, and I want to make sure I can highlight still. Okay, so this time we're going to make a Venn diagram, but it's going to be a little trickier than the ones we have done previously because we're going to do number of students taking 9 or more credits and then number of students who are 24 years or younger. So we have 9 plus credits and then 24 or younger. Okay, so let's highlight the 9 or more credit hours. So that would be everyone in those columns. Okay, feeling good? All right, then we're going to go through and we're going to do the students who are 24 years old or younger. So that would be everyone in those rows. So just like before, except we're going to have to do a little bit of adding to fill in our Venn diagram. So when it comes to the overlap here, we have 7 plus 14 plus 4 plus 1. 11, 12, 12 plus 14 is 26. And then just in the under 24, we have 7 here. And then we got 1 who's in the sort of green only, and then the 4 on the outside. So just like before, I'm still highlighting my, contingency table to sort of work out the numbers, but I just have to do a little bit of adding to sort of put them together in the Venn diagram. All right, on All right, we're going to come and do this next problem in the next video, so stay tuned.